Thanks, Liz. Good evening, everybody. It's really a pleasure to be here tonight. As Liz said, it was just 6 years ago that I stood pretty much right in this spot to present my first book published by the Wisconsin Historical Society Press, the Wisconsin State Parks, Extraordinary Stories of Geology and Natural History. And the press chose this library to launch that book. So it went very well. We felt very welcome here. It went real well, got a big crowd. Nevertheless, on that evening, I was absolutely petrified. I'd never done a presentation before, and like this anyway. And since then, we've gone all over the state, presented at dozens of libraries and book festivals, and I've gotten a little bit more comfortable with it now. In fact, tonight I feel even more comfortable than usual, because tonight I feel like I'm coming home to the Middleton Library, where I had such a good time 6 years ago, to present my most recent book, Wisconsin Waters, the ancient history of lakes, rivers, and waterfalls, also published by Wisconsin Historical Society Press. So we're delighted to be here tonight. And by we, I mean my wife, Gail Martinelli, and my wife and me. Gail is my partner in all that we do. She's in the second row here. She's my partner in this effort and all that we do. She provides me with invaluable help with research, and photos, coaching, managing, bossing, all kinds of things. So much more. So thank you, Gail. Not really bossing. I also want to thank Liz and the other people on the library staff who made it possible for us to be here tonight. And thank you all for coming out on this beautiful evening. Also, if I get a chance, I'd give a special thanks to Kate Thompson. Is Kate here tonight? Are you here, Kate? No, Kate's the acquisitions editor at the press. Knows everything there is to know about that treasure of a wonderful resource, the Wisconsin Historical Society Press. So I want to thank Kate in absentia. Wisconsin Waters. Like Wisconsin State Parks, this is a book about geology and natural history of Wisconsin. And in this case, we view it through different entry points, the waterways of Wisconsin, as opposed to the state parks. And both books include trail or travel guides to help you get out and explore and see close up the evidence of our fascinating ancient history. And I should mention that between those two books, Wisconsin Rocks was published by Mountain Press publishers. It's a guidebook that takes you to 52 geologic sites all over Wisconsin. Somewhat briefer treatments of the sites, but it complements the more historical, deeper historical treatment of my other books. Okay, people often ask me how I got into writing about this topic. And I've been fascinated by Wisconsin's natural settings, its fields, forests, and waterways, since I was about 5 years old, when my older brother John got me out on the first of many hikes around Cumberland in the northwest corner of the state. That's where I grew up to the age of high school. And the first hike we took it was in a place that looked a lot like that. Later we moved to Hayward, where the Namakagon River flows through. And before long, John got me out on the first of many canoe trips on that river. And you can see this is just a few years ago. I quickly fell in love with canoeing and with the Namakagon. I proudly dedicated this book to my brother, John. So regarding Wisconsin's waterways, there's plenty to talk about. Water's so important to all of us here in Wisconsin, as I summarized in the following passage from my book's preface. Tucked into a corner of the upper Midwest, formed by two of the Great Lakes, and bordered on its west side by North America's largest river, Wisconsin is framed by waterways and rich in various water features. Within its borders lie 15,000 lakes. The state is laced with more than 12,600 rivers and streams, that trickle or surge over dozens of waterfalls that mesmerize so many visitors every year. Each of Wisconsin's waterways has a story to tell. And together, these stories create a complex tapestry woven together in time and space by the flow of Wisconsin's waters. So let's look a little deeper into the book. We'll delve in a bit, or actually we'll start with just a quick overview. We'll start with the first chapter, which is a big picture kind of chapter, asking questions like, how did oceans full of water wind up on planet Earth? And how much of that water is available to us? And it's that availability question that was a real eye-opener for me. This slide might help you to visualize how finite our water resource is. Excuse me. This large blue sphere here is represents all the world's water, the world's total global water supply. What it would look like if you could gather it into a sphere. And this next largest sphere here represents all the world's fresh water flowing in streams, rivers, and in lakes. Because the lion's share, that's the fresh water, all the fresh water in the world. Because the lion's share of the total water supply is salt water in the oceans. And then the smallest, tiniest little sphere represents the fresh water flowing in the lakes, rivers, and streams in the world. So it turns out that just a very small fraction of 1% of the Earth's total global water supply is readily available surface fresh water for use by all the plants and animals and all the world's 8 billion people. So Earth has a lot of water, no doubt about that, but it's finite. And my hope is that an awareness of the finite nature of the water supply will be motivated to protect this invaluable resource. Another part of the big picture in the first chapter is the immense time frame for the geologic and natural history of our region. See how this graphic starts way down here at the beginning of the Earth's existence, some 4.5 billion years ago. And it winds up through the eons to a time called the Cambrian period, about 545 million years ago. And that's when life started to evolve and diversify rapidly on the planet. And this graphic proceeds through other millions of years of evolution and extinctions, including the age of the dinosaurs and their extinction 65 million years ago. And all of human recorded history could fit in the last third of this final segment here, called the Holocene epoch, when modern humans first appeared, 5,000 years or so. So the point is that the geologic events and processes that I'll talk about that shaped what the landscapes and waterways in our state took place long, long before we were even around. And a really important aspect of this is that for much of its ancient history, the region that is now Wisconsin was tropical. I want to thank UW geology professor David Michelson for the use of this image. Early in its history, the crust of the Earth was fractured into several large pieces called plates. And these plates were jostled and moved around on the planet, driven by the intense heat of the Earth's interior. It's a process called plate tectonics. And the plate on which Wisconsin rode, the North American plate, was south of the equator long ago. And due to plate tectonics, it got jostled and bumped and moved around, crossed the equator heading north about 350 million years ago, and kept moving and landed in its current position about 10 million years ago. And we're still moving. We're shifting roughly southwest about as fast as our fingernails are growing. And the fact that Wisconsin was tropical for so long explains why there's a lot of evidence of plant and animal life in our state that could only have lived in the tropics. So the next 4 chapters of the book cover regions of the state sketched out here. The book is designed such that you don't have to read these chapters in any particular order to enjoy them. You might want to read chapter 1 first, just to get a review of or an introduction to our geological and natural history. But each chapter begins with a map like this one, showing the sites to be visited, an introduction giving the background on that part of the state. And this is followed by 4 to 6 sections per chapter, each covering a waterway. So there are a total of 19 waterways or groups of waterways covered across all 4 chapters. So let's just do a very quick preview. Chapter 2 covers the northern highlands, shown here, and its iconic lakes, the Lake Superior shore, and 4 key rivers, including the Brule River, one of our favorites, shown here. Chapter 3, the northeast corner of the state, the northeast ridges and lowlands, explains some enticing explores some enticing waterfalls, like this one in Menominee County, as well as important rivers, the Bay of Green Bay, and the Upper Lake Michigan shore, including famous Door County sites like this one from Peninsula State Park. Next is chapter 4. The Southeastern Glacial Showcase covers the lower Lake Michigan shore with its beautiful dunes and other features. It also covers Lake Winnebago, the Horicon Marsh, and our Yahara Lakes right here in Dane County. And we'll talk more about them a little later this evening. Finally, chapter 5 covers the driftless area, the southwest, with its mysterious ancient rivers like the Kickapoo, shown here. Can you see the canoeists in this photo? They're right there. They just slid into view just as Gail snapped that photo from a bluff trail up in Wildcat Mountain State Park. This chapter also covers the lower Wisconsin River, Devil's Lake, and of course, the vast valley of the Mississippi River, shown here from an overlook at Nelson Dewey State Park. Let's delve a little deeper, go to a couple of these specific stories, and after we visit a couple of the waterways in the book, we'll travel back here to Middleton to talk about how the surprising story of the waterways in this area. But we'll start with what are favorite destinations for many people, the waterfalls that grace many parts of our state. And forgive me if I don't cover your favorite waterfall tonight. We'll just touch on a few of them here as we go. Starting with Big Manitou Falls. This is up a few miles. This is in Pattison State Park, a few miles south of Lake Superior in Pattison State Park, which is south of the city of Superior. And here the Black River crashes 165 feet, making it the highest waterfall in the state. This ledge was created by something called the Douglas Fault. What is the Douglas Fault? It was a fracture in the Earth's crust along which a vast block of land was heaved up. When the primitive North American continent collided with a smaller continent to the southeast, and the compression of the crust caused these blocks of land called fault blocks to be heaved up. And one of the faults along which it was heaved up was right this one, parallel to the Lake Superior shore. And the Douglas Fault crops up in various places along the shore. Several streams flow over it, including the Amnicon River at Amnicon Falls State Park, just a few miles east of Pattison State Park. Makes a great day trip to take in both of these beautiful state parks. These waterfalls are located on rivers that are making their way to Lake Superior. This is a photo from Wisconsin's Lake Superior shore. And there are dozens of waterfalls for you to discover in this region. And of course, the big lake itself can keep you exploring for days, weeks, as long as you want. For each of the waterways, I tell the story of how it was formed, and I follow that story with a travel guide that you can use to see evidence of the history close up. So for example, this is one of our favorite hikes. Lake Superior Shore Travel Guide takes you to several of the waterfalls near Lake Superior, including this one, a secluded little waterfall south of Cornucopia called Lost Creek Falls. Lost Creek is one of many little streams that tumble down from the high sandstone bluffs, mounds that make up Bayfield Peninsula to the shore of the lake. Another example of a Lake Superior Shore waterfall is Upper Potato River Falls near Gurney. My travel guide explains that this is part of a 90-foot cascade over ledges of shale and sandstone deposited between 600 million and 1 billion years ago. And this is now 8 to 10 miles south of the Lake Superior shore of the shore of Lake Superior, but for a few centuries after the glacier melted, this waterfall was on the shore of the lake because the lake was full of glacial meltwater. It stood at a much higher level. And much of the land north of this waterfall around the town of Gurney is an ancient delta, a river delta built by the river flowing into the lake during those centuries. So there are wonderful waterfalls for you to visit in the Lake Superior Shore region. But another intriguing array of waterfalls lies in the northeast corner of the state, mostly in Marinette County, outlined in green here. Marinette County bills itself as the waterfall capital of the world, of Wisconsin, sorry. Waterfall capital of Wisconsin. And here's one of Marinette County's waterfalls on the Peshtigo River, where it rambles through Goodman County Park. Now, Marinette County has a wonderful array of county parks, beautifully maintained, where you can visit dozens of waterfalls. Now, why does this area have a lot of waterfalls? Well, the answer, as with most geologic questions, lies in the lay of the land. Marinette County, outlined in various colors here, slopes gently southeast, from the northwestern highlands down to the lakeshore at Green Bay. Also important for this story is the fact that the foundation under Marinette County happens to be a hodgepodge of different rock types, bedrock types, resulting from various processes and events, including continental collisions with mountain building and volcanoes. Lots of action up there. These rock types all vary in their hardness and in their erodibility. And now because of the slope of the land, the streams and rivers tend to flow south or southeast across that county. And they cross this chaotic patchwork of bedrock types. And so whenever a softer rock like sandstone lies next to a harder rock like granite, the stream flowing across that juncture will drop down into the softer sandstone and erode it away, making a hard ledge of the harder rock. And so it erodes this little gully, or not gully, it erodes a small gorge. And this is what happened all over Marinette County. Just as including here at Long Slide Falls on the Pen Bon Juan River. This is in the northern part of Marinette County, near US Highway 141 in Long Slide Falls County Park. And this is where I started my tour of the falls. A little further down south on Highway 141 is another example, a little gorge where the Pipe River slides in a chute between two masses of granite. Here you're looking down about 15 feet to the water from one of those granite cliffs. This waterfall is called Dave's Falls, named for Dave Frechette, the lumberjack who perished upstream of these falls trying to break up a logjam in 1881 at the height of the lumbering era in Wisconsin. Strong Falls is on the Peshtigo River, cascading over hard rock ledges that were formed by centuries of erosion. And you'll find this one in Goodman County Park over on the west side of Marinette County. My travel guide features 10 such sites in a kind of circle tour of Marinette County, of the Marinette County parks. Some of the waterfalls are secluded in deeper woods, and they might be, the roads are not exactly main roads, so it might be a little more challenging to get to them, but it's worth the effort, and you can certainly do it with a good vehicle. My travel guide gives detailed directions for finding each of them. Here's a sample from a part of the travel guide that previews 3 striking waterfalls on the north branch of the Pike River, and they're called 8-foot, 12-foot, and 18-foot falls, all located in one of the county parks. So it goes like this. From the parking area, the trail to the 18-foot falls is a 1/4 mile long on rocky terrain, fairly challenging. This is a favorite among waterfall hunters because of its remote, picturesque nature. All the falls in this county park tumble over granite forged by a mountain building process more than 1.8 billion years ago. And I explain more about that mountain building process in my book as part of the complicated story of how that crazy quilt of bedrock was formed in that part of the state. I took this photo from the top of 18-foot falls. Just about dropped my camera that day into the falls. Glad I didn't. Well, now let's find some calmer waters. We'll leave the northern part of the state and travel south to Horicon Marsh. And I know a number of you in here are familiar with Horicon Marsh. This great marsh, one of the largest freshwater cattail marshes in the world, was venerated by none other than the great writer and scientist, Wisconsin's own Aldo Leopold, in his classic A Sand County Almanac, a reading called Marshland Elegy, as follows. A dawn wind stirs on the great marsh. With almost imperceptible slowness, it rolls a bank of fog across the wide morass. Like the white ghost of a glacier, the mists advance riding over phalanxes of tamarack, sliding over bog meadows, heavy with dew. A single silence hangs from horizon to horizon. Now that's great writing. My Horicon story begins with that quotation, followed by the story of how the marsh was formed. And it was the basin for the marsh was scooped out probably by several glaciers, beginning as long as 2.5 million years ago. And most of that carving was done by the most recent glacier, the one named after Wisconsin. And it created this huge basin that lies mostly in Dodge County. It's about 13 miles long and 4 miles wide at its widest. And as the glacier retreated, this basin was filled with water melting off the glacier to become what's called a glacial lake. It's basically a pool of icy water, melt water. Back then, this area was a tundra that might have resembled this artist's rendition. It would have hosted only the hardiest of ground cover plant species, lichens, mosses, some grasses, eventually stunted trees. The animals in the area included woolly mammoths, musk oxen, mastodons, caribou, and probably large cats like those that you see down here feasting on a caribou carcass. And it's likely that Horicon even hosted giant beavers, larger than today's black bears. They grew as big as 7 feet long from nose to tail. They likely weighed well over 200 pounds, with incisor teeth up to 6 inches long. Evidence of such animals has been found in this and other areas of Wisconsin. This graphic shows how the how the giant beaver compares to the modern beaver on the left and Justin Bieber in the center. And the creator of this graphic considers Justin Bieber to be an average human. I'm not sure that's true, but shows how the giant beaver compares. And for many decades after the glacier had shaped the Horicon Basin and was receding to the north, the area remained a tundra where the mammoths ranged across the plain, munching on the grasses. Here's a picture of Gail getting to know the last of the mammoths up there at Horicon. This is a full-scale replica that stands today like a sentinel overlooking the marsh. It's really neat. The mammoths were extinct by about 11,000 years ago, but they may have watched as humans moved in to the area around 1,000 years before that. Nearly every major prehistoric native culture known to the upper Midwest is thought to have used the marsh, including the paleo hunters who hunted the mammoths and other large mammals called megafauna more than 10,000 years ago. And since then, they were followed by archaic cultures and other woodland native cultures. The word Horicon is derived from an Algonquin term meaning land of clean, pure water. And effigy mound builders had established camps and villages and built mounds all around the marsh in the Horicon, around the Horicon Marsh between 700 and 1200 AD. Many effigy mounds were built in the shapes of animals such as turtles and birds to honor the spirits that these people revered. Some, but not all, mounds served as burial mounds. And one of the best surviving clusters of mounds in the state can be viewed at Nitschke Mounds County Park near the southwest corner of Horicon Marsh. It's shown here. Now, the Horicon Marsh story ends well, at least to this point. This is what it looks like today. But beginning around 1800, the marsh underwent a tortured period. It was first flooded to make way to facilitate logging, followed by overhunting to the point where duck and other waterfowl species were almost wiped out. Later, people drained parts of the marsh to allow for farming, which did not work out. Here's a picture of a plowed area where one attempt to farm the marsh failed completely. In fact, plowing caused the marsh to dry out in large areas, and then the peat deposits under the marsh would catch fire and burn for years, until almost all of that peat up there had turned to muck. So it was a real mess. But then in 1921, concerned citizens joined together, began the long process of restoration and protection of the marsh. And today, it's completely protected, as you see here. The northern part is a national wildlife refuge. The southern third or so is a state wildlife area. And the marsh is even recognized by the United Nations as a wetland of international importance. And you can walk through the marsh on boardwalks and earthen dikes, as no doubt many of you have. I'm sure you have. And you can get close-up views of various flowering plant species. This is a photo that Gail took of a milkweed flower with cattails behind it there. The marsh hosts countless species of insects, including the endangered monarch butterfly that depends on this milkweed. And you will see amphibians and reptiles, and of course, birds. Hundreds of species of birds, including pelicans, egrets, herons, swans, cranes, ibises, martins, you name it. They use the marsh, especially during migration time. This photo and the first one you saw tonight of the marsh at dawn were taken by Jack Barthelme of the Friends of Horicon Marsh. And we owe those friends a great deal of gratitude for their ongoing work to restore and protect the marsh. And I would say the same about any friends group, friends of any park or natural area. Always thank those folks when you get a chance. As with all my stories, I follow this one with a travel guide, basically a driving route around the marsh on county and state highways, but you can also bike it if you want. Lots of people do. And you'll want to start your trip with a visit to the Horicon Marsh Education and Visitor Center, run by the Friends of Horicon Marsh. Again, it has an impressive collection of fascinating artifacts and information. And from the Visitor Center, you can take hikes all over the marsh on miles of trails. To finish at the Horicon Marsh, here's a reading from my book that takes us back to Aldo Leopold. In 1948, Leopold expressed some pessimism about the restoration of Horicon Marsh. Observing the brutal and widespread disturbances to the marsh, he feared that someday, quote, the last crane will trumpet his farewell and spiral skyward from the great marsh, unquote. No doubt Leopold would be pleased to see that his pessimism was unwarranted in the long run. The marsh has survived those disturbances to become a thriving marshland ecosystem. And indeed, this is one of the most remarkable stories that I've ever heard of natural restoration. And I've studied a lot of such stories. Restoration that can occur when people band together, work together to protect and preserve an area they care about. Well, now, as I said, wherever I go to present my book, I like to research and talk a little bit about local waterways. And here in Middleton, the obvious choice is the lakes. Chapter 4 is a section titled The Yahara Lakes, covering the five lakes that we all know, Lake Mendota, Monona, Lake Wingra, Wabisa, and Lake Kiganza, which many of us call the Madison Lakes. The story of those lakes is largely the story of the Yahara River, which flows through all of those lakes. The river has changed dramatically. The river valley has changed dramatically since the last glacier melted out of Wisconsin. This is a photo of a present-day river valley in Iceland. And as the Ice Age arrived in Wisconsin, and Wisconsin became tundra, the ancient Yahara River might have looked a lot like this. And I describe that in a reading in my book. One more reading from the book here. Just before the glacier arrived, Wisconsin must have looked much like parts of the Wisconsin's driftless area appears today, with high rocky hills and ridges and deep river valleys. The Yahara was probably a good-sized river sweeping through the present-day Madison area. Madison's isthmus was a long bedrock ridge around which the river snaked as it made a grand S-turn, flowing through the future basins of Lake Mendota and Monona. Standing at sites like today's Picnic Point on Lake Mendota and Turville Point on Lake Monona, instead of viewing placid lakes, one would be looking down 250 to 300 feet at a wide river winding through an ancient valley. So beginning about 2.5 million years ago, the Ice Age arrived and glaciers inched down out of Canada, perhaps 15 or more times during that long period. And it was the most recent glacier, the one named after Wisconsin, that did most of the landscaping that we see now in the Yahara Valley. At its peak, sometime between 14,000 and 20,000 years ago, the Green Bay lobe of the glacier covered the Yahara River Valley, which would be about in here, right here. And the ice at that point was estimated to be 1,600 feet thick. That's about 114 stories, taller than the Sears Tower. Of course, it thinned out as it got closer to the edge, but as deep as it was 1,600 feet or more. As it was melting back, the Green Bay Lobe was a wall of ice standing just east of where the lakes are now, looking somewhat like this present-day glacier in Greenland. From there, it melted back eastward in fits and starts, and as it shrank away, it calved huge chunks of ice that fell to the newly ice-free land. And then these big chunks of ice were gradually buried by the tons and tons of sand and gravel flowing away from the glacier. And a number of these massive icebergs fell along the axis of the Yahara River Valley. And over the centuries, that ice melted out, leaving the vast pits or basins that now contain the 5 lakes. Such pits were called kettles, or are called kettles. So the Yahara lakes are huge kettle lakes. Almost all of Wisconsin's 15,000 lakes are kettle lakes. Now, as it was melting, water just gushed off the receding glacier, carrying masses of sand and gravel and largely filling much of the rocky Yahara Valley, the ancient valley, with sand and gravel to depths of 300 feet in some areas. And the flowing melt waters formed a big lake called Glacial Lake Yahara, shown here. It's estimated to have been 12 feet higher than today's lake levels. This diagram of Glacial Lake Yahara was provided again by UW geologist David Michelson, who has studied this as much as anybody. On the west side over here, you'll see something called the Johnstown Moraine. That represents the farthest extent of the glacier. And as you know, you may know that a moraine is a zone of glacial deposits, sand, gravel, boulders, that build up sometimes to a high ridge. Here's another moraine called the Milton Moraine. And this is where the glacier paused for just a few centuries, eye blink in geologic time, as it was melting back. This moraine forms the west side of the Yahara River Valley. Now, this is a map showing glacial features of Dane County left by the glacier as it retreated more than 10,000 years ago. There's a lot of detail here. Here are the lakes, the 5 lakes. Here are the moraines that I mentioned, the Johnstown and the Milton. But what I really want you to notice just for now on this map is all these hundreds, literally hundreds of little black arrows. Short black arrows, all pointing in the same direction, all over the Yahara Valley, all in large parts of Dane County. These, they represent another feature left by the glacier, hundreds of teardrop-shaped hills called drumlins. These are areas where just prior to the glacial advance, the ground was frozen rock hard. This area was a tundra, and the ice mass passed over it, sculpted away anything softer, sculpted these teardrop-shaped hills out of that hard frozen ground. And notice they're all pointing in the same direction as the glacial advance, north, west to southeast. That's how we know the glacier created them as it moved along. Most of these drumlins have been leveled or cultivated or quarried for sand and gravel, but Madison still has a few of these drumlins. Here's one, Bascom Hill, well known to the thousands of students who've trudged up and down that drumlin for many decades, with this iconic Bascom Hall sitting up at the top of the hill there. Most notably, Wisconsin's gorgeous Capitol building is perched on a drumlin. Many drumlins stood as islands in glacial Lake Yahara. So were we to instantly turn the clock back to that time, people visiting the state capitol building today would find themselves on an island looking out at a vast icy lake. But let's zoom to another part of the Yahara Valley, namely this area right here around Middleton. Here's a photo of the Pheasant Branch Conservancy looking south from that high hill, Pheasant Branch Hill, just north of town here, one of our favorite places to hike. The story of how things changed in this area is quite dynamic. To begin, let's go back to around 15,000 years ago when the glacier had just started to melt out of the valley. Now here's another glacial landscape map. This one centered more on Lake Mendota. And here's Mendota and Monona. Notice these lighter blue outlines here. This represents the outline of glacial Lake Yahara. And a large arm of that lake, a large arm of glacial Lake Yahara reached up into this area that is now Middleton. We'll zoom in a little closer. Here's the westernmost extension of Lake Mendota here on the right side. And notice how the lake reaches up into Pheasant Branch to the north there, and then stretches to the northwest. At the time, the level of the glacial lakes was much higher than today's Lake Mendota, so all of downtown Middleton, if I can get this pointer to go, including where we are right now, was underwater. We are sitting on an ancient lake bed here tonight. And see how this lake reaches up into Pheasant Branch again and then stretches off to the northwest. What's interesting to me is that this glacial lake at the time was draining to the west through an ancient version of Black Earth Creek, and to the north through an ancient version of Pheasant Branch Creek. And today, as you know, all the lakes drain south with the flow of the Yahara River. So what happened was, as the glacier continued to retreat and the ice melted away, at some point it uncovered a southwest outlet that was lower than those northwest outlets. The lakes turned around and started draining south. And at that time, the ancient Pheasant Branch Creek reversed its direction and started flowing south and east into Lake Mendota. Now let's move ahead in time, a few centuries to the period between 700 and 1200 AD, well before European immigration, when indigenous people thrived in dozens of villages on the lake shores, as indicated here by these red and black dots scattered around all 5 lakes. In those 5 centuries, indigenous people built 1,500 mounds, estimated, maybe more, on or near the shores of the Madison Lakes. And as in the case of the Horicon Marsh, some were effigy mounds, some were burial mounds. This graphic shows how those mounds were distributed in groups all around the lakes, quite a few of them up here in the Middleton area. Now a relatively small number of these 1,500 mounds have been preserved, but the Madison area has the highest concentration of the remaining mounds in the state. And this is a hill just east of and overlooking Madison's Vilas Park and Zoo. Is part of Vilas Park, where 8 mounds can still be found. You can see one in the foreground here stretching down to the lower right, another one stretching away from this tree on the left side of the photo, and there's more that you can't quite see so well here. Below this hill on the other side, Vilas Park was the site of a village where these mound builders lived, fishing waters of Lake Wingra, hunting birds and other small game, and harvesting wild rice. And this is probably close to what the area looked like at the time. I'm sure some of you will recognize this. This is Big Springs, found in the UW Arboretum, where it trickles into Lake Wingra. Many parts of the Arboretum are still quite pristine. And the UW Arboretum is a wonderful resource for all of us in the Yahara Lakes region because it preserves some of the human legacy of the lakes as well as the environmental legacy and the natural legacy of the lake's environment. So when glacial Lake Yahara drained away by around 13,000 years ago, it left the beautiful chain of lakes that indigenous people revered and that we know and love today. And they are, from the top of the chain, Lake Mendota, the largest of the lakes. We took this photo from Vilas Hall, the tallest building on campus. Shows Picnic Point stretching out here from the left, and then, of course, Middleton's over on the other side there. Oops. Lake Monona, with the city skyline across the water there. This photo was taken from Olbrich Park on the lake's eastern shore. Lake Wingra, the smallest of the lakes, probably once part of ancient Lake Monona back in the days of the glacial lake. Lake Waubesa, and this is a photo of the Waubesa wetlands on the south side of the lake, provided by Professor Cal DeWitt. And finally, Lake Kiganza. This photo shows where the Yahara River flows out of the lake just southeast of Lake Kiganza State Park, the end of the chain of lakes that we all value so dearly. So I hope that my book with its travel guides will help you to get out and explore and enjoy all 5 lakes, as well as the 18 other waterways that are covered in the book. So it's been a real pleasure to be here this evening. I'll be happy to sign copies of my book for you after we're done here. For now, though, I'd welcome any questions you might have. Thank you. Yes.
So I live outside of Arena, Wisconsin,
Uh-huh.
which means sand, and
Yeah.
it seems like there's nothing but sand around me. Half a mile from the Wisconsin River. How did that get there?
Well, it's part of the driftless too, isn't it? Yeah, it's in the driftless area, so you can't say that the glacier brought all that sand, but the meltwaters from the glacier flooded that valley. The Wisconsin River Valley was flooded from from wall to wall with water flowing away from the glacier, and probably more than one time, more than one glacier, and just basically troweling unimaginable amounts of sand and gravel across the whole valley and just building it up to deep levels. So it was meltwaters, glacial meltwaters, as far as I understand. Yes?
Regarding the effigies, the one that was kind of by Lake Wingra Park there.
Yeah.
So if I was wandering through there, I would be like, oh, here's a bump.
Yeah.
And so Native American tradition was like oral tradition, right? So how did we get to the point where we knew where these mounds were and we can locate the ones that are still surviving? Is there an obvious answer to that?
That's a really good question, and I honestly don't know all the answer to that in detail. I can tell you there's some really great scholars, including one Robert Birmingham at the University of Wisconsin, who's made this part of his life study. He's written books on the mounds, and he and others have figured out ways to. I think they use ground surveys, walking through, and they just learn how to spot. If it's a shaped rise, if it's a shaped bump, on the forest floor, they can dig down carefully and excavate and see if there's any evidence of that having been built there. And sometimes they'll find artifacts. So it's that, and they're also making use of satellite technology and remote sensing from above. They can somehow, I don't know how, can tell if something is different, if it wasn't part of the original soil or whatever, and they can spot those things from those kinds of images. So that's part of it. I have asked that question a few times, and I need to ask an expert how they found those to begin with. Some are quite obvious, you know, like the ones on the Mendota Mental Health Institute grounds. There's one gigantic long bird effigy that's 60 feet long or something. And then, of course, there's the famous man mound, which is one of the few fashioned after a human being. That's up where? Somebody might be able to tell me. But those are obvious. There are some that are quite obvious. So, but others are found after serious study and exploration.
I'm assuming that agriculture is the primary culprit for having destroyed the majority of them? Just over
Yeah, I think that's a pretty safe bet. Urban development, road building, agriculture. Yeah. Yes?
I was going to say, I worked with the Menominee people for a
Oh,
long
good.
time with the UW.
Mhm.
And the Menominee people know the trails that their ancient ones took when you go up to like UP.
Yes.
And they know where the waterways were because in the winter, they had to survive, so they knew the path to take in the winter. And in the summer, they came back toward Wisconsin. And when they died in the winter, then they were buried there on the trail that they were taking. So that's how they found a lot of them.
Yes.
You know, the natives helped them find them.
Well, that's a source that I should have thought of right away. Native people helping, indigenous people helping the scholars to find these things. Some of them know where they are. So.
And they wanted to bring them back home,
Yeah. Yes.
some of them.
Okay. Yes.
What's the closest waterfall of any size to Madison?
Good question. Well, it depends on what you mean by any size. One of the ones that is enjoyed by a lot of people is Stevens Falls in Governor Dodge. Is it Governor Dodge? Yeah, Governor Dodge State Park over by Dodgeville, north of Dodgeville. That's a beautiful state park with a little waterfall, but it's a pretty significant one. It's not a major cascade, but it's interesting to see how it was formed. That's one. The southern part of the lake has fewer waterfalls because it just kind of all flattened out by the glacier. And then I know there are waterfalls over in the driftless area too. Honestly, I can't tell you a lot about those off the top of my head. And there aren't that many, but driftless area to the southwest, and Governor Dodge is part of the driftless area. And then otherwise you'd need to go north. Well, probably quite a ways north to see some big waterfalls. There's some great waterfall hunting books. Yes?
I was wondering, in your book or anecdotally, do you have any examples of springs, natural springs, and their history and use?
Oh yeah. There are a number of them in the Arboretum, as I said. Big Springs is one. You can go down there and just see that. Have you ever been there? In the Arboretum? Okay. And there are springs out in the driftless area. For example, at Governor Dodge State Park that I mentioned, there's a spring that fills up, that the farmer Stevens, I think his name was, built a little house over where the spring comes out, and he used that for a cold water source. Springs. The driftless area. Oh, Pheasant Branch, yes. Yes, have you ever been to Pheasant Branch? Yeah, okay. That one is amazing. Springs boiling up in that big pool. And then up in one of the most remarkable sets of springs is up at the source of the area where the Brule River originates and flows north. The St. Croix River flows southeast toward the border. That whole big, huge bog is fed by springs. And those are some amazing springs. Some are like a quarter mile across. So I hope that answers your question. Yeah, Janet.
I have a hard time understanding drumlins. I think they're hard to see.
Mm-hmm.
And maybe they're easier to see from the air. But you say they're formed by the advancing
Yeah.
glacier?
Yeah.
Okay, when the glacier retreats erase them.
Well, you see, the glacier didn't really move when it went back. It just melted away. When it was coming down, it was carving up the land. And then it dropped a lot of stuff and carved a lot of stuff and flattened a lot of stuff. And then it melted away, having done its work, and left all these forms, these features. Oh, sorry, Tim, hi.
With the spring question, one more place locally is Donald Park near Mount Horeb.
Oh, yeah.
That's got a big, I think they call it Big Spring.
Oh.
Donald Park. So
Oh, good.
it's pretty cool.
Good to know, thank you. Donald Park, what's the nearest town?
Mount Vernon.
Mount Vernon, yeah, okay, yeah. Yes,
It does.
yes.
Yeah, with the glaciers, as they melted, is it so that the southern edge, being warmer in the south, that melted first, and that sort of explains why the rivers generally are flowing south, but with some exceptions, maybe local, would it be the local depths of the glacier that account for some rivers flowing north, but most seem to be flowing south, at least in the United States.
I believe that the reason for that would be more how the land was shaped, whether it was elevated or was subsided, sunk down. For example, the whole north central part of Wisconsin is called the Wisconsin Dome. It's just barely elevated because during the formation of Lake Superior, there was huge sinking or subsidence of the land under all the weight from volcanic rock. Sunk down and created this big trough where Lake Superior is now. And in part of that process and other more complicated processes, some of the land was elevated. So from the north central part of the state, all the rivers tend to flow southeast because the land is sloping sloping to the west, south, and east off of that dome. And so, but then and then there are divides. There's a divide up there along south of the Lake Superior shore where I'm not sure what caused this. Probably, again, the subsidence of the Lake Superior trough. The water from the divide flows south from, as does the St. Croix River toward the western border of Wisconsin. And then north of the divide, it flows down into the lake, like the Burl River. And then there's another divide in the driftless area where Military Ridge stretches across from Madison. All the streams flow off different directions on those. So it's more the shape of the land, I would say, than the glaciers did carve some of that water, some of the waterways, but it's more the general shape of the land or the lay of the land that determines the flow. Yes?
Do you have another book planned?
Yes, I do. And it's just barely being formulated now. It's kind of in the same vein as these two, but it will be different. It will cover some things that are not in either of these books, but that are really special to Wisconsin. Focusing on things like the Niagara Escarpment, which is what makes up Door County. That's the Niagara Escarpment, that big cliff over Green Bay, that sort of thing. It'll be more of a focus on areas or regions or landscapes and other special features of Wisconsin. So yeah, I don't know how long it's going to take me, but it'll be a while, yeah. Anybody else? Well, thank you.